Hello everyone, let's solve this problem. The reaction between a 0.1 molar primary alkyl halide and a 0.4 molar sodium alkoxide produces an ether at a rate of 0.08 molar per second. Determine the rate of the reaction if 0.5 molar of alkyl halide and 0.1 molar of sodium alkoxide were used. So to summarize, this reaction is reacting alkyl halide with sodium alkoxide to produce ether and sodium halide. So this reaction is a nucleophilic substitution where the alkyl group of the alkoxide replaces the halide of the alkyl halide, giving us our ether. Since the alkyl halide is primary, here, no steric hindrance is involved. Therefore, this will undergo SN2. Now, what are some characteristics we know of SN2 reactions? One of the most important is that it's a bimolecular substitution that involves the simultaneous attack of the nucleophile and removal of the leaving group. A second key characteristic is that the rate determining step is when the nucleophile attacks the alkyl halide. And finally, our last key characteristic is that the rate will equal K, the rate constant, times the concentration of the alkyl halide times the concentration of the nucleophile, which, to clarify, in this case is the sodium alkoxide. Perfect. So now we're ready to begin our calculations. In order to determine the answer to this problem, we need to follow a couple steps. Step 1 is to determine K, our rate constant. Let's review what we know from the problem. We know that the rate is 0.08 molar per second. The concentration of alkyl halide used was 0.1 molar, and the concentration of sodium alkoxide is 0.4 molar. So we need to plug these in to this equation to find K. So let's do that. Our rate is 0.08 molar per second, and it equals our K, which we are trying to find, and the concentration of alkyl halide, which is 0.1 molar, times the concentration of sodium alkoxide, which is 0.4 molar. And we want to get K on one side, so we divide both sides by 0.1 molar times 0.4 molar. We do the same thing to this side, which allows them to cancel out, and we get K on one side. When we divide 0.08 by 0.1 times 0.4, we get 2, and one of the m's will cancel out, leaving 1 behind. So we have it over m, and we still have this s below. So our K is 2 over molarity seconds. Perfect. So step 2 is to now plug this business into K here to determine the rate. Because now that we know K, we also know these concentrations, and we're able to find the rate. So let's do that. So step 2 is to calculate the rate. And to calculate the rate, to clarify, going back up to the problem, we want to use these values, not the values we use to calculate K. The values in the first sentence of this problem were just used in order to find the rate constant K. And then we're going to use K to see what would the rate be of the reaction if we use these two different concentrations of our reactants. So let's again write down what we know. We know that our K is 2 over molarity seconds. We know that the concentration of alkyl halide is now going to be 0.5 molar, and the concentration of our sodium alkoxide is going to be 0.1 molar. Now, perfect. So now we just plug everything in. The rate is therefore going to be 2 over molarity seconds, put in parentheses, times 0.5 molar times 0.1 molar. One of these is going to cancel out. And therefore, we're going to end up with a rate of 0.1 molar per second. Our final answer is 0.1 molar per second. Thank you very much for your time and attention, and I hope you have a great